Come.
Wait 1 sec. Wait a second. I need to put a...
Okay, my name is Gaspar. I'm not... yes, this is me.
Okay.
Thank you.
Come to save. Okay, where am I? Yeah. 1 second. I'll put a link on a learning system. Yeah. Copy link. This will work, I hope. System. We don't have a time to waste, so work faster. Yeah, this one is okay, and I can switch to my table and start talking about today's ideas. I have prepared exactly 4 little beings. What do I have here? I have a signal source. At this moment, what do I have? I have one capacitor, one resistor. This one is microfarad, 600 ohms. Here I have ground, and this is yellow S1. You see it as a yellow line, and this one is a blue line on the scope. Very simple schematics, isn't it? Simple capacitor box, simple resistance. What can we do? We knew electrotechnics theory, basics, yeah? If it's something like S maximal cosine omega, can we do it? Okay, omega is double P multiplied by 4.5 kilohertz. What electrotechnics tell us to do with such voltage? It's a voltage. Looks like voltage, measurable in volts. What can we do? We can represent it as rotating vector, rotates with the frequency omega, yes? Let's say voltage with the dot, because it's complex, yeah? It's rotating vector, and the length of this vector will be, what should we use? What? Electrotechnics theory tell us. Symbolic technique. Have you heard about it? Electrotechnics basics, AC circuits. Starting moment, Heaviside idea. It's original. This idea came from Oliver Heaviside. Later, it's refined by Charles Bartel Steinmetz. What is the idea of AC circuits? Huh? AC generator produces AC voltage. To make real.
This building, other building, before it was 212.
You would. Maybe you know about AC circuits. How do we represent an AC voltage as a vector on a complex plane? Should I call vetoes? Well, do you have a course of the basics of electrotechnics? What? Idea. Heaviside's idea was simple. You have a voltage. Sine you have an AC voltage. To work with it, what Heavisides offer? Very simple idea. Okay, I will erase it. Okay, AC voltage. What I will see if I connect scope here, what I will see? Something like this. Amplitude 230 square roots from 2. Yes? And period for 50 Hertz, 1 against 50 Hertz equals to 20 milliseconds. This is time. Something like this? Why it's square root of 2? Because effective value. Idea is it's our previous lecture. Idea, if you want to use all, see, it was time AC circuits just emerged. People knew something about DC current. So, to make ideas from DC usable, we need to somehow, let's say, lay a bridge between just emerging AC currents and DC. What's the idea of effective value? I have DC source. Where is my battery? Here, I have 24 volt DC battery. What will be equivalent in AC? In AC voltage producing as much energy as DC. Let's say I load this battery with the 600 ohms, it will produce some heat. Equivalent, if I take another one and connect to my generator, when will be equivalent? When this thermal power will be equal. It's called RMS or effective value. DC voltage producing as much energy as its equivalent AC. For ideal sine or cosine, effective value really RMS is square root for periodic signal time S squared. Why? For ideal, I see something like this. This will yield a simple amplitude divided by square root of 2. So for ideal AC voltage or AC current, RMS or effective value can be its square root of 2 factor. That means what? I don't. Now it's disconnected. I have DC network here and AC network here. This one, 220 volts, if I take a key and switch it on. And here, between the lines, also 220 volts. That means what? Any active resistance connected here will be heated with the same intensity as here. Actual amplitude here is 220 multiplied by square root of 2, 141. Okay, returning back. Heaviside's idea. We have something like this. But also, Heaviside knew something about complex number. What is complex? Idea what possibly exists square root imaginary number. In reality, what number produces a minus when squared? Nothing. It not exists in our world. But if we imagine what it can be, we will get an interesting object. One number, if we take an accounting list, table 1, computer mouse 1, monitor 1, number 1, but it has a real part and imaginary part. Meaning, we can operate with the complex plane. Real part, ordinary numbers, and imaginary part of plus 1 number 1 and inside 2 parts. So, if I have something on this plane, this dot tells me what came with imaginary part. A plus B, where A is a real part, A is a real of x. It's an ordinary number. And I can B is an imaginary part of x. Or I can mark this angle. Can I do it? Why not? It exists. B will be length or absolute value of my x multiplied by sine. Yeah? A is an absolute value matic by cosine. I have sine omega t. This one is an angle. So, I can do one thing. I can compare this with this. Similar. So Heaviside's idea was, let's think or let's imagine voltage or current we observe as an imaginary part or projection of some complex vector. Look what I have. Close the camera. It's an AC generator, powered by one Professor Force, 100 volts. Here, I have attached angular scale and a complex plate. Time goes up if we speak on sine as in power industry. Time goes up. Voltage produced by this generator can be assumed as a projection of this small vector representing it's a quadrupole arcs. It's from Park decomposition. Okay, it's from electrical machine. So it's a vector of voltage, and real voltage can be assumed as a projection of this vector to imaginary arcs going up. Have you heard something like this? It's a theory of vector techniques. What a silence. And now, if I have a current, I have to draw a current vector here. Here they are rotating. So in circuit, there is a voltage and operates as current. Both can be represented as a projection of some vectors on a complex plane. Complex plane rotates. For network, I should rotate it with a speed of 50 turns per second. Yeah? If I take this complex plane from the generator shaft, it will no longer rotate. But relation between vectors, will they remain? Voltage current remain, plane no longer rotates. We have voltage. We have, what I'm doing? Current. Yeah? Both can be represented as a vector on a complex plane. This one will be, let's say, starts from 0, this means what voltage is something like this. Because at 0 time, it has angle 0. So, white line. For green line, something like this. So, for 0 time, it works. here will be, for example, current. Here is current at a zero moment, something like this. So voltage will be sine omega t. Current will be sine omega t minus some angle phi. Here it is. Relation between vectors remains constant independently. Rotates complex plane or stands still. Case idea of Heaviside technique. I can omit omega t and operate with a static picture. Steinmetz also introduced idea of complex resistance. Let's look on my network. I have source, let's say sinus omega. Yeah. I have capacitor with capacitance microfarad, and I have resistor. What can I do in a time space? Let's say we have. Can I write the Kirchhoff voltage law here? Do you know the Kirchhoff's voltage law or the second Kirchhoff law? What Google says about Kirchhoff's voltage law? Yeah, the sum of voltage drop on a closed contour equals to zero. Okay? What will be voltage drop on resistance? It's simple. Plus, at what will be voltage drop on a capacitor? What will be voltage drop on capacitor? Yeah, the first derivative. One first derivative or something else?
Yeah.
Derivative. Derivative. What forms the voltage of capacitor? Sum of all charges. Yeah? Why zero? You really think it's zero? I have another idea. What I'm doing here? What I got here is a 1000 volt source. Wait. Here is capacitor. You see voltage? Do I supply energy now? No. capacitor store energy. It's activated. What's going on? I supply energy. I have smaller capacitor here. It charges. When the voltage reaches threshold, this neon lamp being strike through. Pulse of current flows through the primary winding of small transformer, and xenon lamp gets ignition. Now, what voltage is proportional for? Derivative on integral. It's a sum or speed. What's an integral? Sum of all small parts. What's a derivative? Rate of change. Voltage proportional to rate of change or sum of charges? Sum of charges. You see, I need to apply work. It's a hooliganism. Don't play with 1000 volt. It's painful. Sum of charges. Equals 2. Is it easy to solve it? Can you tell the current? Yeah? You think it's easy to solve? How will we solve it? Or maybe something in between. To solve it, you need to take a derivative to get rid of integral. And you will have the differential equation with two rules. It isn't so easy. When the Steinmetz idea. Guys, let's make a functional transform to look the circuit like known AC, no DC current, to apply Ohm's law as usual. Solving this isn't easy. What was the idea of Steinmetz? Okay, first inverter was heavy side, but it was Steinmetz. This one, voltage. What do I have? 1 volt. 1 volt. Actual O max is square root from 2. See the scale. 1 volt. Look on the yellow line. This one is 1 volt. You see the amplitude of yellow line. Approx 1.5. RMS 1 volt. So, circuit will be, I can draw a circuit. 1 volt EMF. Instead of capacitor, what should I write? X equals to 1 Why I'm writing it? If we integrate a sine, what we get? Cosine. 1 against C, we saw it before the integral, sum of all charges. Integrate of the sine is cosine. But if I have multiplied this one is, it means forward 90 degrees. The same thing divided. This one is x divided by square root from -1. It's a rotation backwards to 90 degrees. Cosine is a sine but shifted by 90 degrees. So introduction, 1 divided to mark the cosine. And 1 against capacity from integral. It's a sum of all charges. But if I have a double capacitor, how long should I turn to get the same? Twice, because capacity double. And my resistance. Now, the second Kirchhoff law looks like A equals to current multiplied L XZ. Yeah? It's simple. It's the same second Kirchhoff law. Idea of complex plane allows to switch from trigonometric equations to algebraic equations, but with complex coefficients. See? Now to yellow and blue line. I have, again, this is my signal, this is my capacity, this one is a yellow line, I have my resistor, and this one is the second blue line. Can I write for the harmonic signal, assuming what? Let's say sine omega. Can I write? What can I write? Let's imagine I have voltmeter here. It's showing, and I will attach second voltmeter here. It will show me actual this one and this one, these two numbers, these two digits. Can I write a electrotechnics theory formula for the output voltage? I should call it those. Where is electrotechnics theory? Basics. It should be in previous semester. You don't have electrotechnics theory? 2 years ago. What am I doing here? Output voltage will be current and current is an input voltage divided R1 and multiplied by resistance. Am I right? Can you agree with this? Something familiar, no? And now signals theory. So output is input multiplied by resistance divided by resistance. I can write it in form. Input voltage multiplied by, what do we see in a clock? Is it dependable on input? Do you see any depends from input? No. Can I assume it's a function? Yeah, but function of what? What's the argument? Frequency. It's a complex function of frequency. Or I can write also complex frequency. There's no difference. It's a complex function of frequency. In a theory of signal, we call it transfer function. Output as a function of input. Transfer function. What can we say about this transfer function? Transfer function is resistance divided by resistance plus 1. I would like to draw a chart. I don't know how to draw a complex value, so I will take an absolute value as a function of frequency. How do you think? With increase of frequency, what will happen? Frequency increases. What happens with the transfer function? This one becomes lesser and lesser, lower and lower, and limit, if we say the frequency goes to infinity, transfer function model directs to 1. Yes? But on the frequency decrease, if frequency directs towards 0, what will happen? We will have division by 0 here. Yeah? This means that this part will have infinite value and function goes to 0. So we see function what? Decreases at low frequencies and goes up on high frequency, but it has a saturation, it should be 1. Let's check. Can we check it? Let's see. Frequency, input, effective value, output, effective value. Low frequency, low output. Yes? Higher frequency and output goes up. Now, so, okay. Now they are equal. Yeah? I can draw a chart like this. You see it in literature multiple times. But what's drawn? One moment. This slope usually is related as 6 decibel per octave. What is decibel? What is octave? Usual frequency scale is drawn in logarithmic scale. 1, 2, 4, 8, 16, and so on. On each unit of the horizontal scale, frequency doubles. 1 octave means what frequency 2 against frequency 1 is 2. So step of 1 octave means on each unit of scale, frequency doubles. Decibel. Scale in decibels, it's a 20 decimal logarithms of, let's say, some x1. 6 decibel also means twice. This means what between this point, its signal doubles. So on a slope, before knee point, output doubles on each double of frequency. Here, asymptotic, it will go to unity. What can we say about this network? Do it suppress low frequencies? We have boom, 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 and tss, tss, tss. What will happen with sound after the circuit? What will happen with low frequency, with banks? Suppressed. And high frequency remain unchanged. So we have HPF high pass filter. Circuit that suppresses low frequency and passes high. And what's the name of this port? Amplitude frequency chart, or it has a name, Bode plot, Bode diagram. Bode, it's a name, it's a person. So Bode chart or Bode plot on our amplitude frequency diagram shows actual amplitude or absolute level of transfer function independence of frequency. Good. Till this point, everything is clear. And now press. Nothing special. Just another signal. When we deal with sine, input, sine or cosine, or harmonic output, harmonic. Input rectangle, output. Something wrong here. Yeah? Here, everything is a as we heard by electrotechnics theory, something wrong. Okay, maybe it's a problem of this network. Can I assemble another network? I would like to assemble And this will be simple network, isn't it? So, what will be transfer function of this network? One resistance, one capacitance, what will be transfer function? Maybe Google can answer. Ask the Google. Google, what will be transfer function of this network? What's this say?
Maybe there's a minus.
We have current, it's and voltage multiplied by current. Here it is. Yeah, this is transfer function of this network. Can we plot a chart? Frequency, value of transfer function, absolute value. Of course. I just put resistance and capacitance. What can we say? If frequency goes to infinity, this one where goes to 0, but this one also to 0. And result 0 by 0. So it goes to transfer function leads to 0. Okay, if frequency goes to 0, this one to infinity, yes? And this element also to infinity. Division of them will yield us 1. Let's check. Should be something like this. Yeah? Let's see. Hey, you. Low frequency, 1 and 1. Looks like 0. Frequency goes up and output, look what happens with output. Goes down and ends at 0. So we have low pass filter. Suppresses high frequency, passes low frequency. if I push, take a look. Our input harmonic, output harmonic. Input squares, output something quite different. Yeah? Let's mark it. Electrotechnics theory well works on harmonic signals. But something bad happens when we go out of this nice, cozy, comfort area. For harmonic sine, everything works fine. For rectangles, something wrong. For triangles, no, it's not good. Okay, maybe it's something wrong with capacitors. What should I do to, let's say, solve the question? I should bring the coil here. Signal, resistance, coil, here will be ground, coil. This one is no longer needed. Standard inductor, 10 millihenries. Standard inductor, 10 millihenries. Coil instead of capacitor. Can we write a transfer function? Really? Current will be, and here, current will be EMF divided by R for XL. And voltage here will be current multiplied by coil resistance. That's why it's because current coil voltage is inductance, let's say volume of magnetic capacitance multiplied by derivative of the coil current. Yeah? That means from sine we need to cosine and go forward. Yeah, what can we say about this? If frequency increases to infinity, this one goes to infinity, this one also to infinity, and the ratio will be 1. And if frequency goes to 0, this one 0, this one 0, and the result will be 0. We should see something like this. Yeah? Possible. Can we check it?
There is.
Frequency down, output also down. Frequency up. See, they are equal. What kind of circuit do we have? Low pass or high pass? High pass. Low frequency suppressor. High pass filter. But what will happen if I push the square signal button? Distortion. While we are in a space of electrotechnic basics, in a space of harmonic signals, we see no distortion. Just at the moment we go out, you see the difference. For triangles will be something like this. Signals changes its nature. Okay. It's suspicious, but okay, let's put a mark on it. How many circuits did we solve? 3? What should remain? One more. With coil in series. Yeah? Circuit, let me assemble you. One second. Here's my coil. Resistance, and I need, wait, my voltage. Okay, what kind of network do we have now? Signal, coil, resistor. Output AC. What will be transfer function? Resistance divided by resistance plus coil inductance. What can we say? When frequency increases, where the function goes? To 0. And at low frequency, to unity. Frequency, amplitude of transfer function. Something like this we will see. With the slope on 6 decibel octave, it decreases twicely if frequency increases. But the frequency doubles. It's a low pass filter. Can we check it? Low frequency, we see signal ratio unit. High frequency, it goes down, down, down. Suppresses high frequency and keeps low. But that's not all. Here is a harmonic signal. What will happen? Like triangle, close to side. Something wrong here, yeah? No distortion. Everything is a theory of electrotechnics tells us. When I push this square button, we see distortion of the signal. It changes. Signal is changed. We need to do something about this. The problem is with classic electrotechnics. I can draw. Maybe this will be useful. It's a control switch. Coil in series. Sorry. Is the same what capacitor in parallel low pass filter. Coil in parallel, same as capacitor in series. Frequency. Absolute value of transfer function, high pass filter. And in all cases, we have problem when we go out of the harmonic signals area. Problem. We need to do something about it. Sorry. We need to do something. And of course, giant question, capital question, why we are wasting time on this? We speak on power engineering here. Yeah? Not communications. Why we are taking time, wasting time on the signals? One moment. Let me clean my table. This one. Why all? Because it's in the program. simple object. Where is my sensor? I will assemble a very simple network. Here I'll put resistance on. This will be grounded. This will be first signal, and this will be the second signal. What's it? Okay. Now, current will be here. This is my current, and where is my voltage? I'll bring voltage here. One is for voltage. Network I have. I'll switch. Come on, I'm switching video. Okay, it is. Nice picture, isn't it? Yellow voltage, 200 volts. Blue current, everything fine? Easy. And now everything is fine. This is voltage, and this is current. Let me take another video. Here is a current. Here is a current. Nice. No, this one is more aesthetic. Oh yeah, it's an old fuse. Maybe this one is better.
How do you change the components with a lamp different?
Yeah.
Yeah?
It's because this one have a DC. It's powered by driver, which have the DC stage at the input. It's a current of the LED one. The current what consumes the driver of the LED. KTs.
Which one will be most efficient?
This one has an energy consumption. How again for comparison? As an energy consumption, this one is most effective. But current of the halogen. Blue line, current of the halogen one, I replace it with the here is current of the LED. Blue one. Is it harmonic?
No.
Yeah, wait a problem here. Huh? Wait 1 second. I'll bring in something. Wait a second, I'll bring something more fun. Show it to your safety engineer. My victim. This will be my victim. Let's take a look on the current from the Panasonic laptop. Case, take a look on it. It's a current consumed by laptop. It's harmonic, yeah? It's nice sign. Why? It's a noise from PWM converter of this power supply. It's a computation noise from PWM converter. If everything works well, I'll show you what's inside. If you have time. I have prepared this one with power factor conversion. Correction, sorry. Nice signal, isn't it? So we have problem now. The nice time of ideal ohmic watts is gone.
Frequency it will bring, or it will shut down?
This one more.
It will shut down.
No, it's an active wall. It's independent. I can power it from DC. For when it's driver, it's different. Some goes shut down, some work from DC. Some lights work.
But if the frequency is the left,
For it depends on kind of driver. Simpler, without power correction, most probably will work. For more this one probably will go shut down. Because it needs frequency for peer. Cheaper LED lamps work. Most cheapest not, cheaper what? High end may even burn when powered from DC. For incandescent lamp, frequency is not important, it's a ohmic law. So, what's the conclusion for today? Can we make any conclusion? Most. First, circuit with reactive element are frequency dependent. Yeah? Second, harmonic signals pass undistorted, but non-harmonic signals are subject to distortion in frequency dependent networks. Yeah? It's a second conclusion. And third conclusion, we will face problem with classic electrotechnics theory when start to consider nowadays networks. Because loads, no, modern loads are non-linear. Okay, I think it's enough for today. Or maybe some questions? Mind-blowing, yeah. Okay, I can